Hi friends, so hope you all are doing good. Today we will discuss the concept of orbitals, SPD orbitals, which are important for writing the electronic configuration. So first of all, if I say this is the atom, okay, so this is the atom. So where you can find the electron? Like basically, what is the probability of finding the electron, say in this particular region? So basically, the probability of finding the electron does not become zero even at the large distance from the nucleus. Like if you are this much away from the nucleus, like at this much distance, still the probability is not zero. There is some probability that you can find the electron here, or you can find the electron at this region. So therefore, we can't draw any figure that encloses the region of 100% probability. So it is not possible to draw anything like if I draw a structure, this is the atom, here are electrons. So this is how an atom looks like. No, the probability could be here also, anywhere. Okay. So for this purpose, what we do, we have the concept of orbitals. Now, what are they? Basically, we draw the surfaces where probability of finding the electron is maximum. And these surfaces are known as orbitals. So what are they? Basically, it represents a region around the nucleus in which the probability of finding the electron is maximum. Okay. So atomic orbital is like a function describing the location of the electron in atom, like where the electron is exactly present inside the atom, that is represented by orbital. I hope this is the concept of orbital is clear. Now we have various shapes of the orbitals. Like shape of these orbitals can be represented in terms of boundary surface diagrams. So we have boundary surface diagrams. So what they do, they represent basically the shapes of the orbitals. So there can be many such surfaces, but only we take that shape where the probability is maximum. Basically, maximum could be 90%. So basically, there are some diagrams in which the probability of finding the electron is maximum, and we consider those surfaces as boundary surface diagrams. So basically, now let us move to the first boundary surface diagram, or basically first orbital or orbital. I hope the concept of orbital is clear. So very first orbital is, we have s orbitals. So s orbitals are non-directional and spherically symmetrical. Now what it means? So basically here you can see the diagram of s orbital. So it is basically a sphere, and it is symmetrical. Like this is my z-axis, this is my y-axis, and this is my x-axis. And I have drawn it in the form of a symmetry. So these orbitals are symmetrical. Okay. And basically, the probability of finding the electron is same in all the directions. Like if you start from this point, you go in this direction, you go in this direction, or you go in this direction. Any direction you go, the probability of finding the electron is same, because these all represent the radius, r. So they are same, even in this direction, and this direction. Even here, anywhere. So they all are r. So the probability is same. Okay. So these are known as s orbitals. How to the shape is important. Try to draw it on your notebook because this question was asked in the exam. So how to draw s orbital? Basically, draw the axis, z-axis, y-axis, and x-axis, and make a circle, basically. So this is your s orbital. So now s orbital, so how basically all the time you won't be able to draw this much. So how to simplify it? So we make a small rectangle and we write here as s orbital, and so in a small box we can add 2 electrons. So this is the s orbital. S orbital can accommodate a maximum of 2 electrons. S orbital can accommodate a maximum of 2 electrons and both of opposite spin. One upside up spin and this is down spin. Down spin and up spin. Okay. Just learn this thing. S orbital can accommodate 2 electrons. And what is the shape? Symmetrical, spherical. Okay. Now let us move to the other orbital. So the next orbital we have is p orbital. So basically, depending on the orientation, so they are designated. There are three types: px, py, and pz. So they are of 3 types, and they are so this is symmetrical about x-axis. This is my x-axis, so it is drawn on the x-axis, correct? So this is symmetrical about x-axis. Symmetrical about x-axis. Okay, and this one is along the y-axis, py. So this is symmetrical along y-axis. And this one is along the z-axis. So symmetrical along z-axis. So what are they? They just remember what are orbitals? Basically, finding the probability of electron is maximum. So along the x-axis, so this is the region where you can find the electron. So this is the basically, so what is this shape known as? This shape is known as dumbbell shape. So in this region, you can find the electron. The probability is maximum. Okay. So depending on the orientation of the lobes, so they are designated as px, py, and pz. So how to represent them? So they are of 3 types. P orbital is of 3 types, x, y, and z. How to represent them? Just make again a big rectangle and make, so since they are of 3 types, so write px, py, and pz. So as I told you, maximum how many electrons you can fill in a small box? 2 electrons. So first fill them singly, 1, 2, and 3, then double them. So maximum how many electrons you can fill? You can fill maximum of 6 electrons, 2 in the each px orbital. Okay. So 6 electrons can be filled maximum. First fill the electrons singly and then double them. Suppose if I say a p orbital has 2 electrons. 2 electrons in a p orbital. So how to fill that? So again, just make up the shape. So this is my px, this is my py, and this is my pz. So I have to make 2 electrons. So 1 electron in this and 1 in this. Okay. So don't do like this. 2 in the first. This is wrong. So you have to fill singly first, and then you need to do the pairing. Okay. So next we have d orbitals. So there are 5 orientations possible for d. What are they? Dx square minus y square, dz square, dxy, dxz, and dyz. Okay. So these are the shapes. X square minus y square is symmetrical about the x and y axis, and z square lies on the z axis and has a lobe here. This is a ring along the xy plane. Then we have xy. Xy lies in the xy plane. YZ will lie in the YZ plane. And XZ will lie in the ZX plane. And YZ will lie in the ZY plane. Okay. So 3 orbitals, this XY, XZ, and YZ are similar. They lie between the principal axis. Like this is my main principal axis. This is my principal axis. These orbitals will lie in between the principal axis like this. Okay. For example, dxy. So 4 lobes lie in xy plane. The 4 lobes of dxy will lie in the xy plane. Okay. For dx square minus y square, basically the lobes lie along the principal axis, which is XY. So XY principal axis, this is my XY principal axis. The lobes lie along the axis like this. And for the dz square orbital, it consists of two lobes along the z-axis with a ring in the xy plane. So here we have a ring. So this is my ring, which is along the xy plane, and the lobe is on the z-axis. Okay, I hope this is clear. So every time, as usual, you won't be able to draw these diagrams. So what to do? They are 5. So make a big box, divide it into 5 parts, and name them. So you can name them dx square minus y square and so on, so on. So again, the small box can accommodate 2 electrons. So suppose I have to fill 7 electrons. 7 electrons in d orbital. So what I'll do, so first of all, I will fill them singly. 1, 2, 3, 4, 5, 6, 7. Okay. So then I will do the pairing. First fill them singly and then do the pairing. Okay. Now your question is how many maximum electrons can be accommodated in the d orbital? Comment this in the comment section. Hope this is clear. Okay, then we are done for this video. And if you have any question or query, you can just mail us at the given email ID. Okay, we provide individual tuitions also. So if you need any, you can just mail us. Okay, if you like the video, do share it and subscribe the channel. Bye-bye.